The vector between 2 points. We've met this idea before, but we're going to extend it a bit now. We've met the idea of a position vector. So if we have a point A here, then this is its position vector, how to get there from the origin. So we can give the vector OA as 4, 5. To describe the position of A relative to the origin, we say that OA is 4, 5. It describes how to get to the point A from the origin. So that's where it is relative to the origin. When you see this word relative, imagine that you're standing at one of the points. In this case, you're standing at the origin, and you're describing how you would get to the point A. Relative position does not have to be tied to position vectors. We can describe the relative position of any 2 points. It's simply a description of how to get to one point from another. So let's suppose we have this point A and this point B. I can get there by going 6 across and 3 down. So that's the position of B relative to A. I'm standing at A and I'm describing what I need to do to get to B. Now we can actually tie that back to position vectors. Let's first of all say that AB is 6, -3. We can see that straightforwardly enough. Now let's consider that A is the position vector of the point A, and that B is the position vector of the point B. The vector A, as we can see from here, is -1, 5, and the vector B is 5, 2. Now, B take away A is 5, 2, take away -1, 5, and that gives us 6, -3, so it gives us AB. So AB is given by B minus A, and this is called the turnaround rule. It works in general, so to find AB, the relative position of B from A, remember that means you're standing at A and describing how to get to B, AB can always be given by B minus A. And remember in this that B means the position vector of B, in other words, how we get to B from the origin, and A is the position vector of A, how we get to A from the origin. We can also write that as AO plus OB. So the minus A goes backwards from A to O, and then the OB goes forwards from O to B. So what we're saying here, let's suppose this point is A and this point over here is B. Then we have this direct vector that goes between them, and that would be the vector AB. If the origin is here, we can do that same journey by going back to the origin and then forwards to B. So this is the vector B, this is the vector minus A. So AO is minus A. And of course, OB is equal to B.